room, which I'm sure there's a lot of people. We're at our fall KBMP meeting in Ashland. We have the same exact sequence starting off. Dave, followed by Caitlin Boise from Res, who's going to talk about some things that I think early on it's hard to take data and immediately turn it around, and tell a story about what's happening with dam removal. It takes time to quality control your data, get it finalized before you can assess it. So I know there's a lot of information we're yet to hear from folks, but I appreciate Caitlin being able to kind of give us at least an early view into what's happening. So especially compared to kind of what was modeled. Caitlin, thanks so much.
Right, yeah, so I'm going to take us back to drawdown last year and talk about model versus observed conditions and water quality during the Juvenile Salmonid Management Plan monitoring period of the Klamath River Renewal Project. And that's kind of a mouthful, but I'll talk through what the Juvenile Salmonid Management Plan was, sort of what assumptions it made about what conditions were going to be in the river, and then how we implemented that plan and what that actually looked like. So in case you go and look for this plan after I talk about it, the full name is the Juvenile Salmonid and Pacific Lamprey Rescue and Relocation Plan, but I'm going to be referring to it as JSP throughout, if that's a little bit less of a mouthful. And the JSP is part of one of the many management plans that was approved by FERC prior to license surrender and drawdown. And it sits within the Aquatic Resources Management Plan. And at a high level, the JSP was a resource protection measure to minimize impacts specifically to out-migrating juvenile salmonids during reservoir drawdown and dam removal. And as the name implies, this would potentially have involved the rescue and relocation of juvenile fish. And more specifically, the JSP and this potential need to remove fish was related to two water quality triggers. The first being a 7-day average daily maximum temperature in tributaries of greater than 19 degrees C. And the second being suspended sediment concentration in the mainstem Klamath that remains above 1,000 milligrams per liter. And for those of you who think a lot about fish outmigration and fish refugia, these two triggers might be obvious, but for those of us who don't, the sort of assumption of the plan is that every year juvenile fish are sitting in the tributaries, and as temperatures begin to warm, they will naturally start to make their way to either the mainstem where temperatures are cooler or to outmigrate. So this is an influence that happens every year. However, during the drawdown year, they might be trying to make their way into the mainstem where SSD is elevated. And so there's no longer a refuge for them in the mainstem. So these two influences are creating kind of inhospitable conditions on either side for these juvenile fish. And I will say that these two triggers weren't kind of an automatic requirement to move fish. If we hit them both, it was more of a decision point where additional scrutiny and data might be collected. So this would involve something like snorkel surveys to document the observed behaviors of juvenile salmonids in these tributaries over time. And these decisions would be made and recommendations would be made by a group convened for that very purpose, which is the Aquatic Resources Group, or the ARG. And this is a group of tribes and agencies and technical experts who helped develop the JSP and then were providing input at that point on what sorts of impacts might occur to juvenile salmonids and what sort of measures needed to be taken. And then last year, we're supporting the implementation of the plan, helping make decisions and provide input and recommendations. So this map shows our monitoring locations for the plan, and the green spots and the called out tributaries are where those temperature monitoring spots were occurring. And then the yellow two locations are the mainstem gauges where SSC was being monitored. And this stretch was chosen both based on modeled SSC and historic temperature data in these tributaries. And theoretically, any of these could have experienced conditions that contributed to a potential need to rescue and relocate fish. but 3 tributaries in particular, Bogus, Shasta, and Scott, were called out as being more likely to require this, basically due to historic temperatures and fish use. We know that fish are using the confluence areas of these tributaries and restricted to those areas in the summer as temperatures are warming. And so these are kind of the 3 where additional attention was paid for planning for this effort. And so we can kind of look at an example of what planning for the JSP looked like prior to implementation. And this is from the Shasta River during a median water year. So the potential for all of these actions was looked at across a range of water years. This is a median water year. And you can see our monitoring period, which is March 1 to July 1, kind of when the bulk of outmigration is occurring. And the periods when SSC was modeled above 1,000 milligrams per liter in red. I'll note that I'm just calling out the periods after May 1st because we weren't expecting temperature exceedances prior to May 1st. And then as well as the potential for temperature exceedances in the Shasta itself. And we had kind of this early indicator temperature of 17 degrees C, so that's what's called out in yellow, and then that water quality temperature trigger of 19 degrees C in orange. So we look at these 2 features, these 2 triggers, and we can identify this is the period when we have the likely potential to need to rescue and relocate fish. And as planting is occurring, we can also look at typical kind of outmigration timing, with the darker colors being when the peak of outmigration is occurring, those lighter shaded areas being sort of the shoulders of that outmigration. And this helps us kind of think about level of effort. So are we gonna, if we do end up needing to move fish, are we gonna be moving tens of fish, dozens of fish, or are we gonna be moving hundreds of fish? So that was kind of how this planning effort took place with the members of the ARG, like I mentioned, that developed this plan. But then how did we implement it? So JSP implementation involved 4 main parts. Temperature loggers installed in 13 tributaries and offloaded weekly by Karuk and Res Fisheries teams. We see an example here in the mouth of Cottonweed Creek. Continuous estimates of SSC, and then fish observations were an important part of this implementation as well. And then all of this data being provided in weekly meetings and updates to the ARG. So we'll talk a little bit more about what we actually saw and how it was implemented. So before I throw these temperatures up here, we can see our 13 tributaries across the top, and then this is our monitoring period starting with March 1st through July 1st. And the 7-day average daily maximum temperatures will go up here, but I'll note that they're also going to be color coded. So green is periods when no temperature exceedances occurred. Yellow will be that early indicator of 17 degrees C was exceeded, and then red will be the water temperature trigger of 19 degrees C was exceeded. So our tributaries really experienced kind of a range of temperatures across this period, but hopefully what sticks out is that we're really focused on this early to mid-May on period where these tributaries were starting to warm beyond these temperature triggers. And the other piece of this that I think is, again, key to remember is that when these exceedances occurred, we weren't necessarily immediately going out and rescuing and relocating fish. This was an opportunity for heightened monitoring, additional snorkel surveying, discussions with the ARG to talk about what conditions look like. And you'll notice a couple missing and incomplete data mentioned here. We did have Dry Creek, which became disconnected from the mainstem Klamath at the end of the monitoring period. And then some incomplete data where we had a logger actually get thrown out of the water for a period when it was offloaded at that point. And these times when these exceedances were occurring are also a time when maybe we are focusing more on both fish observations, but also what SSC is doing in the mainstem. And SSC was a little bit more complicated. We typically measure turbidity in a continuous way, not SSC. And so for the purposes of this portion of the project and implementing the JSP, we were using low-range turbidity sensors and high-range turbidity sensors to create a continuous record of turbidity. I will say that even at Iron Gate, there are some gaps in what turbidity was doing during that time, as many of you saw. We were on the group data portal watching that turbidity. But we were able to use this near complete continuous turbidity record along with discrete biweekly SSC graph samples and data from USGS mixing tank experiments in a linear regression analysis to estimate continuous SSC. And SSC is the threshold which we're looking at for fish. And it's more easily translatable to fish health than the turbidity that we're recording in real time. And these estimates of SSC were being updated continually. We were at the beginning of the JSP monitoring period, we had a handful of graph sample results back and available to conduct this analysis. And as we went on, as we got more results back and had more data to go on, we were refining that regression analysis, refining what our results were saying, also providing that information to the ARG every week. It was a really transparent process as we were making these changes and shifting this data. And I'm going to show the SSC data that we have from last year, but I do just want to note before I do that, for those of you who spend a lot of time on the USGS website, you might notice that our SSC looks a little bit different than theirs. Notably, it looks a little bit higher. And that's really due to two factors. The first is that we incorporated these high-range turbidity sensors and those SBU units into our estimates. And we also filled in some gaps in the data using things like linear interpolation and downstream gauge data. And that was really because we were trying to provide these updates in real time. We were trying to manage these dynamic conditions in real time. We wanted to be protective of fish and we wanted to be more conservative if possible, meaning we know these are estimates and we want to err on the side of assuming higher SSC rather than lower SSC so that we're not leaving fish in the river when they maybe need to be rescued or relocated. So this is going to start on January 1st, so we can kind of see drawdown through the end of the JSP monitoring period on July 1st. And you'll notice that the y-axis here is going from 0 to 45,000 milligrams per liter. And I'll throw Orleans, Syad, and Iron Gate up here, along with that SSC threshold trigger of 1,000 milligrams per liter. A lot of SSC, as you can see in the early part of the project. And the two big takeaways from this are the project really functioned as it was designed. It was designed to flush out sediment when we had this period, which typically experiences high flows, typically experiences higher turbidity in the winter, and when it would be the most biologically protective of salmonids in the mainstem. And that's what happened. We can see March 1st, when the JSP monitoring started, the bulk of that sediment moved out prior to when we considered the kind of juvenile outmigration period started. The other piece of this that I want to highlight is just the dilution as you move downstream, and we've talked about this a lot in different KBMP presentations. But Orleans there in green, house here, did exceed this threshold, but really only did so through the end of February. And this is why the JSP monitoring was focused kind of on the reach from Iron Gate to Syad. That sort of spatially contained it because the dilution and input from tributaries as we move downstream was expected to kind of keep Orleans and the reaches downstream from exceeding those thresholds when juveniles were in the river. And so we'll zoom in on the JSP monitoring period, and these sort of small peaks down here during some of those geomorphic flow releases from the upper basin are going to become our larger peaks on this plot. So now our y-axis is going from 0 to 4,000 milligrams per liter. And we did have some exceedances during the JSP period. Those were pretty brief and showed pretty quick returns to ever lowering baseline conditions. But the other big takeaway from this is that we did not see temperature exceedances, if you remember back to that table, until mid-May. So once juvenile fish were starting to get find themselves influenced and pushed out of the tributaries during high temperatures. We had relatively low SSCs compared to what we had had during the bulk of the dam removal drawdown period. And that was not necessarily anticipated, but it was a great outcome of this data. And then finally, the last piece of kind of the observations that came out of the implementation of this plan were our fish observations. So like I mentioned, when we would hit one of those thresholds, especially in temperature, that was a point for us to do additional surveys, additional monitoring to make sure we weren't seeing signs of fish stress or fish overcrowding in these tributary confluences. So overall, we conducted 34 snorkel surveys across 11 sites and observed juvenile coho at 8 of those sites during those surveys. But during none of those surveys did we observe any fish behaviors that warranted rescue and relocation. And this data was all being collected, all of these fish observations were being collected on a weekly basis, reported back to the ARG so that that group could discuss, add additional input, and make recommendations on actions to take for the next week. So what were some of the outcomes and big takeaways of the JSP implementation? We did not see temperature and SSC triggers simultaneously exceeded, despite the modeling predicting that that might occur in quite a few locations. And we also didn't observe conditions that warranted recommending the rescue and relocation of fish. And I think the other piece of that is that the group was never really at odds on what those recommendations would be. There was never a time when half of the ARG thought conditions warranted that, half didn't. We were always kind of all on board and in agreement on our continued monitoring of the plan. And we can say that the assumptions about conditions and model values in the JSP were more protective of fish than what we actually observed, which is great. You always want to be erring on that side rather than being scrambling to implement this type of measures. And then I also really want to highlight the collaboration and dedication of the ARG, which was instrumental to implementing this plan successfully. We were providing data to this group the night before these weekly meetings were occurring so that everyone could review and have questions and input ready to go so that our discussion the next day would be really fruitful and people would have questions. They would be able to provide their on the ground observations, and without those folks and their knowledge, the implementation of this plan would not have been as smooth. It would not have been as successful. So we really appreciate however many meetings, weekly meetings that is, from March 1st to July 1st of those groups participating and coming back week after week to talk about juvenile salmonids. So with that, I want to highlight that there was a huge team that made this happen, both in the planning and the implementation phase, both from RES, Crude Tribal Fisheries, Scott Wright and CVEC, and then the Crude Water Quality team and USGS team, who were collecting a lot of these grab samples, making sure that these stations are up and running day after day. And thank you all for being here to hear about it. I'm happy to take any questions at this time.
If you're relocating fish, where are you going to relocate them? And the second is there's still some turbidity. So do you think that in the summer that's going to make it the water cooler or warmer having that turbidity in there?
Yeah, so first question about where do you relocate fish? Toss can probably talk about this in more detail than I can, but there were locations identified. There were off-channel ponds that were identified, and some upstream reaches that were identified as having cooler spring and summer temperatures. Luckily, we didn't have to rescue and relocate them, but there were locations identified for kind of each stretch of the river, and each tributary where fish would be moved. And then the second question about turbidity and temperature. There is increased turbidity right now, but it's pretty low. And I think, we saw a big increase during the flood operations that were happening earlier in the spring, but I think this summer turbidity is not going to be as big of a factor in the mainstem. So, I mean, we'll be watching to find out, but yeah, we don't know for sure.
How well organized is your water temperature data? Is it possible to share it with some?
That's a good question. Do you have an answer to that, Dave?
Well, I can't answer how well it's organized. Knowing Caitlin and others on our team probably pretty well. And yeah, we can share that information, but, just need a written request from them.
That, I haven't gotten any water temperature data but possible degrees, so that's a special thing.
Treasure trove, temperature data, yeah.
What is the period of record for that monitoring? It was just a couple of months ago.
Yeah, it was probably a few weeks prior to March 1st, and then all those monitors got pulled on July 1st or the weeks following July 1st, but, yeah, we can get you what we have.
Okay, great.
Can you go back and re-explain what numbers were used for your 7-day average and what you guys arrived with number 2?
Yeah, so I think 19 was picked as sort of a pre-mortality and lethal level of temperature, so that if we were rescuing, relocating fish, it was occurring before we were reaching sort of lethal temperatures. And that was something that was, developed as, very early on with the JSP process and informed by local input and National Marine Fisheries input and CFW.
So the 7-day average is
A 7-day average daily maximum. Yeah. Which is a pretty standard, temperature metric. Thank you.